So I am Dr. Chisum Rezedi. I've been the one writing the contents on Medical Research Society. And I've been reading your feedback, most of them positive. So thank you very much. And some of you also mentioned that I should post some videos. So this is me doing exactly that, showing you how I analyze my data sets with Python. So to be able to make this video, I reached out to some of my colleagues, asking them to send me clean data sets, and those that were able to do so on time, the first 5 persons, I used their data set for this video. So thank you everybody for sending in your data set. So quickly, I'm going to show you how I analyze my data on a typical day with Python. So before now, I had developed a class, Python class. I called it Analyze. So that essentially helps me to analyze my data set, and I'm going to show you how. So the names of the 5 datasets, I relabeled them to these datasets 1, 2, 3, 4, 5, and all of them are CSV files. For some of you that have a background in Python, to load a dataset, you use the pandas library, and it's very simple. Pandas, the alias is PD. I use the alias of PD, which is the conventional thing out there. So pd.read_csv, and then you load in the data set. For me, I'm loading in the data set 1, like I mentioned earlier. I don't know whether you can see this clearly. Let's expand it to 150%. Okay, so I've loaded the data set. Now these two codes, lines of codes, is to show you the maximum rows and the maximum columns, otherwise it truncates that. So what I mean, this exactly is showing you the first 5 columns, but if I remove this and click on this, it shows you every single row down to 300, and if I can remember, let's see, 364. So there are actually 365 rows, because if you're conversant with Python, it starts with what? 0. So it's 365 rows, and then it shows all the columns. So to be certain about that, let's click on the shape. So it's 365 rows, 34 columns. So I don't want it to be this lengthy. So let's go back to the first 5 rows. So that's it. 1, 2, 3, 4, 5. Again, this is a short video, so I'm going to skip the tutorial, talking about what all this thing means. I just want to show you how I analyze my data set on a typical day. So like I mentioned earlier, I developed a class called Analyze. So this class essentially churns out summary statistics for numerical and categorical data, hypothesis testing like student t-test, Man-Whitney U, chi-square, ANOVA, Crystal-Wallace. So essentially it checks whether the data set, numerical data set, is parametric, non-parametric, and it applies the tests, statistical tests as needed. Then correlation analysis is very important for me, and then of course regression analysis. I can't do without this really for some of my analysis, because it shows me the predictive variables, what works, what doesn't work, and of course this allows for some adjustments. So let's get right into it. So I want to analyze data sets 1. Can you remember what we did earlier? We had assigned data set 1, this CSV file, to I call it a variable, to a variable called data. Okay, forgive me if I'm not using the right terms, but I call it variable. So again, this is the Analyze class. I'm not going to show you the code because it's copyrighted, and well, it's my intellectual property and all that. So this is my code. Took me months to develop this code, several debugging and whatnot. Kept tweaking and tweaking and tweaking until I got it to its perfect state. So this is the Analyze class, and I'm putting in the data, that variable that I had assigned to dataset 1, and I'm putting everything back to check. So that's it. So if I'm now trying to check the summary statistics of the numerical variable, so this is it. So check that normal. So all these things here are the numerical variables. This actually tracks whether it's parametric or non-parametric. If you pay attention, these last two are parametric, and that was why he used mean plus or minus standard deviation. But the rest were actually non-parametric, hence he used median and interquartile range, the 25th to the 75th percentile. So this is what I do. And if I want to check that of the category, the summary statistics, this is it. So there's an age category 9 to 11 years, 5 to 6, 6 to 8 years, gender, I think this is socioeconomic class, whether there's premature male, premature female, history of diabetes, da 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 da. And so that's it. There are many more, but I'm just going to focus on just the summary statistics, or if you want, we can move ahead. And yes, before I get to hypothesis testing, let's quickly talk about how to save this. So you can remember the first one, check.normal, it showed us all this. Can you save it? Yes, you can save it. So check.normal, and let's save it. Let's not forget this because it's a method. So let's save it to a file called normal.csv. I don't want the index, so index is equal to false. What is an index? Well, let's go back and let me show you. This is an index, 0, 1, 2, 3, 4. I don't want that. I just want name, mean, range, and then normal. If I want, I can drop this. I can remove this completely, but for the purpose of this video, let's just include it. And I enter to save. And then going back to my folder, that is it here, the normal CSV. So I'm clicking on it. This is an Excel spreadsheet. I'm copying the entire thing. I'm going to a Microsoft Word. Let's say this is results. You're writing your results section. Okay, and then coming down here, you can say table 1, and you can name it anything you want to name it. I don't know. And then you can come down here and paste the table. Okay, and of course you have to redesign the table. Usually this is what I do to get it publication ready, auto fit, expand to Windows, and I'm good to go. I can remove this because I don't need it. I just inserted it there to track whatever it is that I'm doing. So again, so this thing here, it happens sometimes, and to prevent that from happening, I had created another method to just address this. This happens when you're using things in Excel file. I don't know why, but I created another method to address this. But for the purpose of this video, let's keep it simple because of time and your data, and that's it. I'm good to go. You can change everything here now at this particular level, or back here you can just change everything here before you can save, but it doesn't really matter. The work has been done. If you're using things like SPSS or I don't know, Stata, I don't think you can get it this fast and this easy. I know this because I've been using SPSS, and trust me, one of the issues I have with SPSS when it churns out the data is having to reformat, rewrite, retype. Oh, so frustrating. So the same thing you can apply to the category, the summary statistics. Remember, this is it. Check.category and then the brackets. So you can come down here, change this to category. Again, let's just come down here and remove this because this is a file name that you're saving it as. Again, index false. I don't want these numbers. I've showed you this before. I don't want all these numbers, so I'm saving. And if you come back here, let's delete this very quickly. If you come back here, see the category, and that's it. The entire data set. Again, coming back to your Microsoft Word, paste and reformat. Reformatting shouldn't take you up to a minute. It's actually less than that for me. Just quickly go to table, remove this, click on this, come to layout and click on this, auto fit, and you're done. You're literally done. You can just put this center. I don't know, do anything you want, but the information is here, nicely placed, no errors whatsoever. Percentages, if you add it up, they're up to 100. Everything well placed, and it doesn't matter what the columns, how many columns there are. If there are 100 columns, you're going to get this feedback from beginning to the end, and you're done. You're sincerely done. There's no issues whatsoever. Let's not save this. So going back to this hypothesis testing, let's say for instance the sex, because this data set has sex, and you want to find out what is the hypothesis or the statistical differences between male and female with regards to the numerical variables. So I'm going to take a different approach. There's a method called t-tests, and the arguments include the column and then the uh, variables inside that column. For me, it's male and female. Where did I get this male and female from? Well, if I go to this data set, let's just quickly remove this too. If I go to this, my main data set, look at the sex. So this female and that's male. And well, that's not going to the different types of gender. For us here in Nigeria, it's just male and female, and that's it. Male, female, and the column name, sex. So that's it. This is the column name, sex, male, female, and I'm using t-test value, and I'm assigning it to a variable called gender t-test. So if I click on this and I click on that, so that's it. Well laid out. Oh my god. So this is the different columns, age, that says total, the overall subjects, the mean, because it wasn't median and it's a total range, so I know already that it was according to this parametric. So 7.91 plus or minus 2.05 for the male, that's it. So it's actually normally distributed with equal variance, so that's why it's reporting it as means. And then the statistic is that for those who are writing their PhD or dissertation, some of them require this. And p-value, it's not statistically significant, it's not less than 0.05. And then going to socioeconomic class, it wasn't normally distributed, so man with mu was applied, and it reported its values as a median, interquartile range. This was a statistical value, and the p-value definitely less than 0.05. It was significant, and hence the asterisk on top, and so on and so forth. So that these are the values. Again, this can be saved and transported to Microsoft Word, and going to chi-square. What about the categorical variables across gender? And that's it. Like I said, publication ready. Total female 180, male 185, the statistics, the p-value, everything beautifully laid out. In fact, let's save this. So if I want to save this, there's a method I use. So the name of this is gender underscore chi. So let's change this to gender underscore chi, and let's change the name of the file to chi index. Do I want the index? Yes, I want the index because the index is actually the names. So I want the index, so that's true. And so I'm saving it, and then going to the folder, let's delete this. Going to my folder, where is it? So that's it, gender underscore chi. I'm copying it. I'm going straight to my file. I'm pasting. And that is, and I am done. Like, I'm literally done. Again, I'm trying to format this very quickly. It takes me less than a minute, and I am done. I'm literally done. Everything well laid out. This is the end value, frequency, percentages, frequency, percent. And if you add everything up, it gives you 180. If you add all these things up, the percentage, it gives you 100. These are the p-value. Once you see this 0 is actually equivalent to this. Okay, all these things here, they're all significant, so equivalent to this. So I make some of these few changes, and if, like I said, it doesn't matter the number of columns. It doesn't matter if this is up to 100 or 1,000 columns. You will get everything in this format, saving you lots and lots of time. Like when I was analyzing this data, I think I needed just the first 6 or so. I can delete all this, or I can come to this level and delete it. It really doesn't matter. I like leaving everything as is, because at a glance I can quickly see those that were significant, statistically significant, and it gives me that direction of what step to take next. So that's it. So I don't want to go into regression. It's essentially the same thing. Just key in the values and then you get the result, and you can, in publication ready formats, which you can copy and paste in Microsoft Word. Again, everything done very quickly. I haven't written out a single word or retyped anything. They're all ready, just waiting for me. Now I'm going to this. Can you analyze multiple data sets at the same time? Yes, you can, because it's very possible. I have these 5 data sets already in my file. I don't know what I've shown you. Let me show you. So it's in my folder, dataset 1, 2, 3, 4, 5, and these are the datasets here. The names, I included it, this called a list, and assigned it to a variable called dataset. Now this is called a dictionary. There's a reason why it's here, and I'll show you. So now I want to analyze the summary statistics of these datasets at the same time. So can I do that? Yes. Again, I'm not going to go into details for some people, who understand Python, and I'm encouraging you to learn. If you don't know what it is, there's something called enumerate. It's a method, and all you need to do is just say function, sorry, and all you need to do is to use a for loop. Then this first I here is the index, J is actually the contents of this. It loops through the dataset content. So this dataset that is a list, once you put it here, it loops through every single thing here. So dataset 1, dataset 2, and so on and so forth till it gets to 5. So what I'm essentially saying is that inside this dataset, loop through everything here while taking note of the index. So index will be 0, 1, 2, 3, 4. If you're using R, this will be 1, 2, 3, 4, 5. I mean, there are 5, but for Python, it starts with 0. So the index, that's the I, is 0, 1, 2, 3, 4. Okay? So what I'm essentially saying is that for each index and for the contents of these data sets, read the data sets. So data is equal to pdf.read.csv. So this is me loading the data set. So it loads this first data set. It assigns, it instantiates it, using the Analyze class, and then it stores the results. It stores the results inside a dictionary, also called result. And to track the key, I decided to use the name of the data set. Again, I don't want to go into details, just accept whatever I'm saying with faith. And then if I click on this, I'm done. So if I want to check the category of the summary statistics of the first data set, all I need to do is result dataset 1, and this is it. Everything that we've set so far. If I want to check that of 2, I click on 2. So this is the second data set. If I want to check 3, I click on 3. That's it. If I want to check 4, and that's 4. If I want to check 5, I'm done. And if I want to save everything, I'd already written out the code earlier, on, and then I forgotten what that's called. I had to use the comment key # to sort of comment it off. So I removed this, so it's an actual code now. So if you pay attention to this code, this is essentially saying for the answer, that's for the result, save it to a file. This is the name of the file. Remove the .csv, change it to .category, and then end it with CSV. And then remove the index. Okay, this is the index. Remove it again. Just don't worry about the code. This is just me trying to demonstrate something. So if you look at this is dataset 1 category, dataset 2 category, dataset 3 category, dataset 4 category, dataset 5 category. So these are all the summary statistics of every single dataset here for the categorical variables. And if I want to do for the summary, that's for the numerical variable, all I need to do is to come here, change it to normal, come here, change it to normal. Of course, I have to click on this to empty this thing and create a new fresh dictionary that's empty. Come here, change this to normal, okay, and save. And then going back here, you can see that dataset 1 normal, 2 normal, 3 normal. I don't want to open this one by one because I want to be sure that you've gotten an idea of what I'm talking about, but you can check it here. So this is the dataset 1, the summary of the numerical variable. This is dataset 2, the summary of all the numerical variables. This 3, summary of all the numerical variables. 4, summary, and then 5. And again, it's tracking. Is it parametric? Is it non-parametric? And it's giving me all the values. And it's amazing because you can do this and save yourself a lot of time come here, just open it up, copy paste into your Microsoft Word, and you're done. So in a nutshell, this is exactly how I analyze my data set, and I hope you've enjoyed this video. And yeah, this is data analysis with Python tutorial. See you next time, and let me know your comments or your feedback concerning this video. Thank you. Bye.